Hello everyone, and yeah, very good evening. Good evening, Siddharth, Divakar, Srividya, Madhu. Super good evening. Great. Hi, Sheetal. So, how is it going? How are you feeling with the intermediate batch? Comfortable? Easy going? Cool. So, last question, I think it was a bit hard that we did in the last session. Like it was, yeah, comfortable. Great. Enjoying Aries. Great. So at least if not summers are getting hot and hot in North India. So watch recording now I'm getting great. In South it's raining. So glad to know monsoon is approaching, and hopefully in few weeks it will start raining here as well. So today was very hot day here. In South it's actually like winter. Really? Is it really like winter season in South? Oh my. Then I should visit South. I should plan a trip to South. Oh, 48 in Ahmedabad. That's too much. All right. So, weather discussions aside, let's begin with today's session. 50 at Bikaner. Oh my God. So that would be like I can't even think of how hot it would be. 50 degrees. We are in 40s and we are just like cannot live without AC. It's all right. So welcome to the session on subarrays. Uh, So this is something we already introduced you in one of the arrays classes. So today's class you will find little easier because we already know what subarray is, and I think we also solved a problem maximum subarray sum. Do you remember we solved this problem? Maximum subarray sum. How many approaches we did for this problem? Maximum subarray sum. Three approaches. Okay. N cube, then n square using prefix sums, and then order n using a for loop. We did three approaches. Great. So some part of today's class would be more like revision. Okay. Because I have to cover the complete topic in this class. So some parts you might feel repetitive, but I will not. We will not take up the same questions. We'll try to do little differently. Okay. So let's start with a quick recap of what is a subarray. Okay. So a subarray, as you know, it's a continuous part of the of an array. Okay. It can start from any index. Sonam says, "What is Kedane's algorithm?" Sonam, actually, I will tell you. Okay, I will tell you. So the one algorithm that we did to find out the maximum subarray sum, that is actually known as Kedane's algorithm. The third one, the third approach we did in maximum subarray was actually Kedane's algorithm. Okay, so you do not need to memorize algorithms by name. It's just for knowing purpose. That approach is called as Kedane's algorithm, and yeah, that's it. and even a complete array can be a subarray. Okay, it even a single element can also be a subarray. That is what we have learned. They are also subarrays. Is empty array subarray? If I say I have an empty array, will that be considered as a subarray? Likely not. Okay, it's not considered as a subarray. It's not a subarray. Empty array is not a subarray. Okay. Okay. Let me take an example. Let's say I have a array which looks like this: 3, 4, 5, 6 minus 2, 8, and 10. So now you have to tell me. I'm drawing few examples. Uh, are those examples a subarray or not? Okay. So if I talk about the elements 5, 6, minus 2, is it a subarray? Of course, yes, it is a subarray because it is this part of the array. Okay. Is 6, 8, 10? Is this a subarray? The answer is no, because this index is missing. It is not continuous. Is 6 a subarray? Yes, because it is a single element. Is 8 comma 10 a subarray? Yes, it is a subarray. Okay, so that means you understood that what a subarray is, right? Okay, let me give you another question. Let's say I have uh, this as my array, right? And I want to count. Suman says why 6, 8, 10 is not a subarray. Suman, if you look carefully, 6, 8, 10, it's not continuous. If I talk about indices, okay, so I told you that if I have a starting index I and an ending index j, so a subarray should contain all elements from index I to index j. So 6 has a index 3, 8 has a index 10 has a index 6, so it should actually contain from this index to this index, that is 3, 4, 5, 6, all these indices it should contain. But now the element minus 2 is missing, so this is missing, so hence it is not a subarray. Okay, it is not a subarray. And there is another concept. So can we say two subarrays? No, no, we cannot say it as two subarrays. We are talking this array as a whole. So that is true that we are combining two subarrays here, but the resultant array is not a subarray. Combining two subarray does not give you a subarray. Okay, Matlab, it may give you, but it may not give you. In for example, if I say 3, 4 is a subarray, yes, 4, 5 or 5, 6 is a subarray, and if I combine these two, 3, 4, 5, 6, and since it is a continuous part of the array 3, 4, 5, 6, hence all three examples they are subarrays, but 6, this example is not a subarray. It's not a subarray. Rest everything is a subarray. Got it? So there is a related term that is sometimes used that we call as a subsequence. Have you heard about subsequence? Some people are saying yes, some are saying no. Okay. So if I talk about what is a subsequence, it is something, maybe some parts of subsequence can be like, if I say okay, I have an array like this 1, 2, 3, 4. So it is actually a subset of the array. which may or may not be continuous. Which may or may not be continuous. So that means uh, if I have 1 2 3 4, can you tell me all the subsequences of length 1? All the subsequences of this array of length 1. What are all smaller parts of array which have length 1? 1 2 3 4. Okay, so 1 is a subsequence. 1 is also a subarray, it is also a subsequence. 2 2 as a single element is a subsequence and it is also a subarray. 3 is a subsequence and it is also a subarray. Great. What about length 2? How many subsequences we can have of length 2? Okay, so Vinay says 4C2, absolutely correct. See, out of 4 elements, you can choose any 2 elements in 4C2 ways. Okay, that means 4 into 3 by 2, that is 6 subsequences are possible. Okay, so if I take the first element as 1, what could be the possibility of picking the next element? What elements can be combined with 1? So I can combine either 1 with 2 or 1 with 3 or 1 with 4. That all will give me subsequences of length 2, right? So I say, okay, 1 2 is a subsequence, 1 3 is a subsequence, 1 4 is a subsequence. Are you getting it? What about 2? If I pick first element as 2, so 2 3 is a subsequence, 2 4 is a subsequence. Now out of all these subsequences of length 2 that we have generated, how many of them they are subarrays? So the ones which are continuous, they will also be subarrays. So 1 2 is continuous. Okay, so 1 2 is also a subarray. 1 3 1 4 are not subarrays. 2 3 is a subarray. That's it. So 1 2 uh, 1 2 is a subarray, 2 3 is a subarray, 1 2 3 and 4 they're also a subarray. What about length 3? uh Sonam, why not 2 1? So 2 1 is same as 1 2. Okay, order does not matter, it's a subset. So when you say set, the order does not matter. Okay. Oh, 3 4 is missing. Yes, 3 comma 4 is missing. Yes, thanks for reminding. So we have 1 2 3 4 5 6. We have 6 subsequence. What about length 3? So it will be nothing but 4C3. Out of 4 options, we have to pick 3 elements. So that means 4 ways. So can I say one way could be 1 2 3, another way could be 1 2 4, another way could be how much? 2 3 4. Oh, 1 3 4. 1 3 4. And another could be 2 3 4. So we have actually 4 ways. Great. What about length 4? It will be 1 2 3 4. That means 4C4, which is actually equal to 1. So there is actually one subsequence, that is the subarray. Oh, that is the array itself. So we have yeah. So out of these, we have this is a subarray, 2 3 4 is a subarray, 1 2 3 is a subarray. Okay. And what about length 0? So there can be a set of length 0. That means if I don't pick any element, then there is one such way. So how many total subsequences are possible for length 4? So that means if I take uh, 0 length, there is one option. If I take length 1, 4 options. Length 2, 6 options. Length 3, 4 options. Length 4, 1 option. So what is this total? 1 plus 4, 5 plus 6, 11. 15 and 16. So there are 16 options for length 4. So can you come up with a formula? 3 4 is a subarray. Yes, 3 4 is a subarray. Length 0 is not a subarray. Yes, length 0 is not a subarray. The green ones, they are considered as a subarray. Okay. So can we say that if I want to find out the number of subsequences, see what we are doing? For every element, there are two options, that either it can be a part of the subsequence or it will not be a part of subsequence. Does it make sense? For every bucket, there are two options. Either this element will be included in the subsequence or it will not be included in the subsequence. Okay. So two options, two options, two options, and two options. So what about the total number of ways? The total number of ways would be 2 raised to the power 4. That is actually 16 ways. Are you getting it? Amina says length 0 is a subsequence y. See, I just told you that there are two options for every element. Now suppose this element chooses I will not go into the subsequence. This says I will not go into the subsequence. This says I will not go into the subsequence. This says I will not go into the subsequence. So what is the subsequence? It is an empty array. So empty array is a valid subsequence. It's not a subarray, but it is considered as a valid subsequence. Okay. So there is a difference between having the number of subsequences versus subarrays. Sometimes subsequence is also called as subsets. So these two terms are related. Okay. And for an array of length n, for an array of length n, yes, empty array same as a null array. Yes, kind of. Uh, for an array of length n, the number of subsequence would be 2 raised to the power n. That is one thing that you can remember. Okay. So anyways, this class is about subarrays. Yes, 2 raised to the power 4 means every element has two options, either yes or no. Yes, either it will be part of the subsequence or it will not be part of the subsequence. So if you consider all possible combinations, you will get these 16 combinations. Okay. So what is 6, 8, 10? Is it a subarray or is it a subsequence? It is a subsequence. Okay. So 6, 8, 10 is a subsequence. It's not a subarray. Okay. So that means you understood the point of the difference between subarray and a subsequence. Okay. Now my first question is that given a subarray, okay, let's take an example. Let's say I have 4, 2, 10, 3, 12, minus 2 and 15. Let's say this is the array. I want you to count how many subarrays are there which are starting from the 0th index. Count subarrays starting from 0th index. Let's say indices are 0, 1, 2, 3, 4, 5 and 6. Okay. People are saying 7. So one subarray could be this 0 to 0. Another subarray could be from 0 to 1. Another could be from 0 to 2, 0 to 3, 0 to 4, 0 to 5, 0 to 6, and 0 to 7. That means, sorry, 7 is not there. So that means we have 7 subarrays. Great. What is 7 factorial? Eh, Is it exclamatory or what? Or is it factorial? Sagar? Factorial? No, no, it's only 7 subarrays. Why? We don't care about the order of elements, okay? We just need to know what elements, like we keep the elements in the same order, okay? For example, 4 is a subarray, 4 comma 2 is a subarray. So there will be only 7 subarrays, not 7 factorial subarrays. 4 to 10, 4 to 10, 3. Okay, so this will go on. So we have only subarrays, okay? Count the subarrays starting from the zeroth index. That means they include the zeroth index. Include, you have to include this index. Okay, that is what the question is. Okay, now tell me how many subarrays you have starting from the first index. Oh, I means one. Let's say starting from the first index. Okay, so now it will be 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5 indices, okay, and from 1 to 6. So clearly you have 6 subarrays. Great. Now you can generalize, right? If I talk about how many subarrays I have starting from the ith index, subarrays starting from ith index. Okay, people are saying n minus I, which is correct. Starting from ith index. For example, if I have this index I and the last index is n minus 1, this is index I. Now I know that one subarray would be this one, this one. Another subarray would be from I to this, another would be from I to this, another would be from I to this, another would be from I to this. So effectively, out of n elements, okay, out of n minus 1, I have to subtract this much. Out of the last index, if I subtract, so effectively I just need to count how many elements are these. How many elements I have from I till n minus 1? Who will tell me? The number of elements. That will be the number of subarrays. Yes or no? See, the starting point is fixed. The starting point of the subarray is fixed as I. The ending point can be either I, or it can be I plus 1, or it can be I plus 2, or it can be n minus 1. Yes or no? So now you just need to count that all these possible pairs, they are forming subarrays. So how many elements are these? Absolutely correct. So Sheetal says n minus 1. See, one way of looking at it would be from 1 to n minus 1, you have n minus 1 elements. And if you also include this I, uh, you will have how much? You will have, sorry, it will be not n minus 1, it will be, so look at this, okay? So the total number of elements, they are n, and from 0 to I minus 1, how many elements you have? You have I elements from 0 to I minus 1. So you subtract them, right? So it would be nothing but these elements would be nothing but n minus I. That is one way of looking at. Another way of looking at it would be till this index, whatever you have n minus 1, you subtract this index, so that will also give you the number of elements. So you can say minus of I minus 1, this will also give me n minus 1 plus, sorry, plus 1 and minus I. So 1 goes off and it will be n minus I. So either way you look at it, it will give you that okay, I have n minus 1 elements in this range or in this region, and hence the number of subarrays starting from the ith index would be n minus I. Did you understand this? Let me know. Ral just got it, okay? Nitin says, can you please explain again? Sure, Nitin. So let us do one example. If I say, okay, you have 1, 2, 3, 4, 5. So if I ask you how many subarrays you can make starting from the element 4, so that subarray would be nothing but 4. Another would be 4 to 5. Another would be 4, 5, 6. Another would be 4 to 7. 4, 5, 6, 7. And another would be 4, 5, 6, 7, 8. Okay. So what I'm saying, the number of subarrays is nothing but it is the last index of the array. Okay, that is 7. And since 4 can be combined with all of these elements, and 4 cannot be combined with these elements. So out of total elements, okay, so total elements is how much? The total elements is uh, actually 8. The total elements is 8. And 4 cannot combine with how many elements? It cannot combine with 3 elements. So how do I get this 3? So that is nothing but the index of 4. So n minus I. So that means 4 can combine with all of these elements. That means out of 8 minus 3, 4 can combine with 5 ending indices, and hence it can form 5 subarrays. Got it? Nathan just got it. Okay. 4, 5, 6, 8. Or 4, 5, 6, 7, 8. Okay. So yes, this is this is correct. Okay. No, 4, 5, 6, 7, 8. It was. I just made a mistake. Is it clear that there can be n minus I subarrays starting from a index I? Okay, now you need to tell me that given n array elements, how to find the total subarrays. Can we use this result that we have just derived? N is the number of elements or the index of the element. So, Sonam, n is the number of elements, okay? So the last index is n minus 1. So one option is you see out of total elements, how many elements should I remove? The other option is out of the last index, you subtract this index. So you can say 7 minus 2, that is also 5. Or you can say 8 minus 3, that is also 5. Both ways are fine. So look, can we use this concept to find out the total subarrays that we have? So what we just discussed, that if we are given array of, let's say, size n, so number of subarrays starting from the 0th index, okay, from the 0th index, that means it will be like 0, 0, 0, 1, up from 0 to 2, and it will be from 0 to n minus 1. So we just saw that there would be n such subarrays. If I start from the first index, I will have 1 1 1 comma 2 and so on, and from 1 to n minus 1. So I will have n minus 1 subarrays. Then I will have n minus 2 subarrays. And in the last, how many subarrays I will have? If I'm at the last index, so this will form only one subarray which starts from this index. It would be 1. So effectively the total count is nothing but it is the sum of the series n into n plus 1 by 2. So we have proportional to order of n square subarrays. Okay, and this is the exact count. How many subarrays we will have? This is the exact count of the subarrays. Okay. So now if the question says I want to print all the subarrays, what would be the logic and what would be the time complexity of that? If the question says I want to print all subarrays, what will be the time complexity of this? So when I say print all subarrays, including the values, okay, including the values of the subarray. Look carefully. Think in terms of code and what you're going to do. How do you print a subarray? Is printing a subarray order 1 operation? Is printing a subarray order 1 operation? The answer is no. What? How you will find out and print all the subarrays? Will it be still n square? Okay, Mohammed says n cube, Sagar says n square, Sheetal says n cube. Just think carefully. We have done this problem in the class. Finding all the subarrays in the maximum subarray sum problem, the first approach. Come on, guys. See what you need to do. If you want to print all the subarrays, right? So you need a starting point. Okay. So you need a loop that decides the starting point of the subarray. Let's say I. So I is okay. I will start a subarray from 0, and I can also start a subarray from the last index. So we keep a loop to decide the starting point. Okay. But now if I start the subarray from the ith index, the ending index can start from I or it can end somewhere after I. So what should I do? Can I say for some j which starts from I, j less than equal to n minus 1, j plus plus. So can I say now I know that the sub array is given by the array from I to j. The array from I to j is what the sub array is. This is what the sub array is. Yes or no? Okay, so these two loops together, they will run n into n plus 1 by 2 times. That is correct. So we will have these many subarrays. But the question says that we want to print a subarray. We want to print all subarrays. So when I'm going to print a subarray, I will need to do work for this. I will have to say for some k which goes from I and k goes till j. What I need to do? I need to say print array of k. And then after this loop, I say okay, print a new line. That means even if I know that okay, there is a subarray from index 2 to 7, I still need to iterate on this subarray to find out what are the elements of this subarray. or in order to print out the elements of this subarray. So what is the overall complexity of this code? Okay, so now we know that in the worst case, this loop will also run n times, and hence it is n square subarrays into order n work for printing each subarray. That means the overall complexity would be order of n cube. Okay, so that is how you find out all the subarrays. What about space complexity? It is still order 1 because we are not using any extra space. We are not using any extra space. Okay, let me give you another question to solve. Vishaka, we just discussed what we had done earlier, that how do we find out all the subarrays. So the question was to print all the subarrays. So we keep a loop to decide the starting point I. We keep a loop to decide the ending point j, and j we know it will be greater than equal to I. So j starts from I, j goes till the end, and array I to j gives us a subarray. In order to print in order to print the array from I to j, we need another loop. Okay, we are just getting two indices, right? We need to suppose your array is like 0 1 2 3. Let's say these are the indices and the elements are some x y z and w. Okay, so now I is going from 0, j is going till, so when I is 0, j is uh, 0, j is 1, j is 2, and j is 3. So what we are saying, that okay, you got a subarray from 0 to 0, you got a subarray from 0 to 1, 0 to 2, 0 to 3. So when we say 0 to 0, I need to iterate and I need to print, okay, x is a subarray. Then in the next iteration it is from 0 to 1, then I need to print x and y. So I'm iterating over 0 to 1. In the next iteration I need to print x y z. So I say x y z. Okay, something like this. In the next iteration I iterate 0 to 3, so it becomes x y z and w. So this loop is doing the work of printing. User, are you getting it? So same goes with every iteration. Okay, so let's see, there is a question. You need to print out the sum of all subarrays starting from an index 2. So let's say the subarray looks like this. Zero, 1, 2, 3, 4, 5, 6, and 7. Okay, so you need to print the sum of all subarrays starting from index 2. So can you tell me how you will do it? What could be a possible approach to solve this problem? One loop, two loop, three loops. Mm-hmm. Okay. See, one option could be that we say, okay, I know the starting point. Okay, so I say, okay, let's decide the ending point. So j starts from 2, j goes till n minus 1, j plus plus. So I now know that okay, there is a subarray from index 2 to j. I know okay, there is a subarray from 2 to 2, 2 to 3, 2 to 4. Now I iterate over the subarray. So I say okay, for k equal to 2, k less than equal to j, k plus plus, and every time I say okay, my sum is 0, and in every iteration I'm saying sum equal to sum plus array of k, and I print out the sum. Does it make sense? So in the first iteration, what we are doing, we are saying okay, j is 2. That means find out the sum of this subarray from 2 to 2. So when j is 2, I say okay, the subarray is from 2 to 2. That means this element. So k iterates over this array and it gives me the sum 2. So in the next iteration, j is 3. That means 2 to 3. That means the elements are 2 and minus 1. This is what the elements are. So k iterates over this array and it gives me the sum as 1. In the next iteration, j is 4. That means the elements of the subarray are this 2, minus 1, and 6. So I iterate over this array and I say okay, sum is 0 and k is going from this index to this index, and hence sum is 2 minus 1, 1 plus 6, 7. And this we keep on doing, right? So this is a basic way of doing it. Can we do better? Can we do better? Can we carry forward some and then printing some for every iteration? Absolutely correct. So you can use the carry forward idea here. You can say okay, in the beginning the sum is 0. Now I know that if I'm talking about the sum of this subarray, it can be easily derived from the sum of previous subarray. So this sum is something that I already know. So how do I get 7? So can I say I will simply add 6 to the previous sum. So so it is carry forward or prefix sum. It's kind of a similar, okay? So what I'm saying is that you say okay, for j equal to 2, j less than equal to n minus 1, j plus plus, and now I say that okay, what I will do, I will add the current element to the previous sum. I'll say okay, sum equal to sum plus array of j, that's it, and I can print the sum. See what is happening. I said sum was 0, great. I went to the second element, I say okay, add it to the sum, so sum becomes 2, I got 2. I say okay, go to the next element, minus 1, add it to the sum and print the sum, so it becomes 1. Go to the next element, add it to the sum, 1 plus 6, it becomes 7. So we are still getting the same answers. Why? Because this sum is containing the sum of the subarray from index 2 to index j minus 1. This sum is already known to us, right? So here we even did not need to build a prefix array. We just computed it directly. Okay, so we are just carrying forward the previous sum. Okay, so we can print sum in every iteration. Okay, Swati says please explain again. Swati, what part is not clear? Sum. Okay, so let's look at this. Okay, so what will be the subarrays that we have starting from 2? So 2 comma 2 would be a subarray, 2 comma 3 would be a subarray, 2 comma 4 would be a subarray, 2 comma 5 would be a subarray, 2 comma 6 would be a subarray, and 2 comma 7 would be a subarray. Okay, so can I simply say that if let's say the elements are 7, 3, 2, minus 1, 6, 8, 2, and 5. So my first subarray is 2 comma 2, and initially the sum is 0. So I simply said that sum is equal to sum plus aj. So what is j? J is starting from 2. So 0, 1, 2, 3, 4, 5, 6, 7. So now sum becomes 2. Great. That means we know this subarray is now 2, right? So when I say 2 comma 3, that means I'm including these two elements. So I already know the sum till this point. If I add this, right? If I add minus 1 to this sum, so it will become 2 minus 1, that is 1, which is fine. The sum of these two elements is 1. What about 2 to 4? So 2 to 4 can be written as sum till 2 to 3 plus the current element. That is 1 plus 6, that is 7. So I get the sum till this point, okay? Then 2 to 5. 2 to 5 can be written as sum till 2 to 4 plus the fifth element. That is 8. So 8 plus 7 is what? 15. Are you getting it? Okay, now you know the sum till this point. You want the sum from here to here. What do you need to do? Just add to the previous sum. So it will be nothing but 15 plus 2, 17. Got it? And so on. And the final sum would be 22. This is what we are doing. So we are saying, okay, so sum is now storing the sum from index 2 till j minus 1. And if I add the jth index, it will give me sum of elements from 2 to j. That is what I wanted. As simple as that. What about time complexity? Order n, great. Space, order 1. Okay, so instead of 2, if we had in the question print sum of subarrays starting from index I, what you will do? You will simply replace j with I. That's it. What if the question demands indices from I to j? Then it is even easier. If the question says I just want the sum of elements from index I to j, so iterate on that range, find the sum. That's it. So we have a doubt that is this your question? That what about sum of elements from I to j, Mohammed? Or you want, or is it something else? So it's very simple. You can say, okay, for k equal to I, k less than equal to j, k plus plus, and sum plus equals array of k, and sum is initially 0. That's it. So just iterate and add. That's it. Okay. What if we take 3 element in subarray? Subarray can have any number of elements. So do you mean 3 consecutive elements? Then also it is easy, right? So you can say that, okay, I want to find out the sum of a subarray, all subarrays which contain 3 elements. So what do you need to do? You need to start from every I, and you need to go to this element I plus 1, I plus 2, and I plus 3. Not even I plus 3. You can say that, okay, for some k which is equal to I, k is less than equal to I plus 2 and k plus plus. Okay, and that means sum plus array of k. Okay, and this you do it for every I. If you do it for every I, you will get sum of all subarrays of size 3. Are you getting it, Kuldeep? So the idea is start from every I and just consider the next 3 elements. So this loop is ensuring that we are only considering the next 3 elements. What happens if I take 1 element from the left and 2 remaining from the right? See, that will be covered now. That will be covered as a different subarray. So if I say, okay, I have a subarray where I want to compute the sum of subarrays of length 3, that is the question, right? Sum of subarrays of length 3. I think this is what the question is. Now, if you are saying that, okay, I am saying that, okay, I will start from this index and I will add the next two elements into it, right? But Farooq says, what if I want to take one element from here and one element from here? So in that case, when you find out the sum of this subarray, which was starting from this I, that will already handle it, okay? So there would be some starting point of the subarray, and when I said do it for every I, all cases would be covered. Can you tell for subsequence of element size 3? So subsequence we will do in some other class. It involves some more concepts which we are yet to cover. So will you be able to solve it? Sum of subarrays of length 3. Bhavna says explain again. Okay, let me repeat a little bit for Bhavna. So Bhavna, it's actually pretty easy. So the question, we had a doubt that how do we find out sum of subarrays of length 3? Yes, it is less than equal to, right? See, I plus 0 is the first element, I plus 1 is the second element, I plus 2 is the second element. So that means you have considered three elements now, starting from the ith index. So Bhavna, I'm saying that if you want to find out the sum of a subarray of length 3, you need to iterate from ith index, which can be like this for I equal to 0. What could be the last index where I can get a subarray of length 3? This is n minus 1, this is n minus 2, this is n minus 3. So can I say I is less than equal to n minus 3 I plus plus? I go to every starting point, and from that starting point I start a subarray. So for that subarray, let's initialize the sum as 0. Then what we need to do, we need to put this loop here. So I just need to say for k equal to I, k less than, okay, either you write this condition or you write this, k less than I plus 3. That means I don't want to go till I plus third, I want to go before it. K plus plus and sum equal to sum plus array of k, and this will give me the sum of subarray of length 3, and since we are doing it for every I, we will get it. So I simply say print the sum. Are you getting it? Yes, there will be a double loop, right? You will need a double loop, right? Understood. Great. Time complexity would be, no, it will not be n square. Now you know this loop is running how many times? This loop is running only three times, na? So it will be 3 into n, which is order of n, because 3 is a constant. Although it is a double loop, but it is still order of n because 3 is a constant. Okay. But the above loop will also run n minus 3 times. So you can say 3 into n minus 3, which is 3n minus 9. So again, this is a constant. We ignore it. So it is still order of n. Got it, Muppa? Okay, so let me change the question a little bit. So question is, how many subarrays from an array of length n would contain index 3 inside them? So we have a array, okay, and we have the indices as 0, 1, 2, 3, 4, and 5. Okay, so now we have, let's say, 3 minus 2, 4 minus 1, 2, and 6. So how many subarrays would have the index 3 inside them? It's not about the starting point. Inside means anywhere inside the stub array, not just start, anywhere inside. So we are getting a lot of answers. Hmm. So the correct answer is, I think it's going to be 12. So I don't know how you computed 11 7, but let's see what we can have. So now can you tell me what is the first subarray which starts from 0 and it will contain this element? Subarrays which are starting from 0. So it will be the subarray 0 to 3. Then there will be subarray 0 to 4, 0 to 5. These subarrays would obviously contain the third index. That means here to here, here to here, and here to here. What about if the starting point is 1? So 1 to 3, 1 to 4, and 1 to 5. Great. What about starting point is 2? So it will contain 4 to, sorry, 2 to 3, 2 to 4, and 2 to 6. Okay. And S is, let's say, 3. So from 3 to 3, 3 to 4, and 3 to 5. That's it. These will be the subarrays that will contain it. Yes or no? So what are the options for starting point? How many options we have for the starting point? If this is the third index, then from 0 to third index, we can have any point as a starting point. What about the ending index? So the ending index should be at least 3. At most, it can be the last index. So ending index can be either 3 or it can be 4, it can be 5. Okay. Now 0 can club with all these values. 1 can club with all these values. 2 can club with all these values. 3 can club with all these values, right? So how much it is? Can I say number of options for the starting, that is 4, into the number of options for the ending, that is 3, that is 12 days. Are you getting it? So this is also 12. 4 cross 3, it's 12. So 12 subarrays would contain this, right? Understood or not? Okay. So can you generalize this? If you understood it, can you generalize this for an index I? Mupa says take one more example. So we will take it, but I want you to consider, try to generalize for how 3 comma 3 is a subarray. So 3 comma 3 means the starting point is 3, the ending point is also 3. Index, that means a single element, that is minus 1. So I want to generalize the same question. In how many subarrays index I would be present? Uh-huh. So just think of it, okay? Okay, so I'm giving you a break, okay, for about 15 minutes, and we don't have much topics left for today. We'll solve one interesting problem after the break, which will take our time, okay, and yeah, so we'll start the class at 10:20, okay, so you have a 12-minute break, and we'll also discuss this one, okay. So welcome back. So okay, we are waiting for the answers. So we have got already a lot of answers. So let me discuss. Okay. So now, if you want to include an index I in your array, let's say you have an array and you want to create a subarray out of it, and such that the subarray includes the index at the ith place. So what does it mean? So it means if you want to start the array should not start uh, beyond I. That means the starting point of the array can be any element that is less than equal to I. So how many options you have to pick the starting index? From 0 to I. How many options you have to pick the starting index? Okay. So the starting index can be picked in I plus 1 ways. Yes or no? From 0 to I. Anything can be started, including I. Okay. Including the element I itself, the subarray can start from the ith index itself. So how many indices you have? You have I plus 1 ways to pick the starting index. That is what we did in the previous problem also, that if you want to include 3, you can start from anywhere from 0 to 3. That's what we did. What about the ending index? Where the array should end given it starts from any of these indices. It should either end at I or it should end after I. Does it make sense? The ending of the array should be after or equal to I. That means even if the array starts from I, it can end at the same index. That means the ending of the array can be at index I, or it can be any index up to n minus 1. So how many elements you have from I to n minus I? We have already learned this in today's class, that from I to n minus 1, we have n minus 1 possible ways. So now each of this way, like these are the options to pick start, these are the options to pick end. Any start can combine with any end. So what is the total ways? The total ways would be nothing but I plus 1 multiplied with n minus I. Okay, so this is the correct answer. Everyone who gave this answer is absolutely correct. Let me know if you have still any doubts in this one. So we just did the same thing as the previous question. We took the product like we did here, and we counted in how many ways we can end the array. We can in how many how many indices we can end the subarray. So that is from I to n minus 1. That means there are n minus y ways. Let me know if you have any doubts. No doubts? Great. Great if you don't have any doubts. So then let me give you one final question for today. The question is actually it's a hard problem. Little hard, okay, but you can still come up with a basic solution. Okay, so let me write down the question here. So you can say, given an array that contains at least two integers, okay, one part of the array is unsorted. Okay, that means one sub part of the array is unsorted. So you need to tell the indices of and rest array is sorted. Rest of the array is sorted in increasing order. Let's say you need to tell the indices of the smallest subarray that needs to be sorted so that entire array becomes sorted. Did you understand this question? Okay, let me give you an example. Okay, let me give you an example. So you have a big array, and one sub part of the array is unsorted, and rest array is sorted in increasing order. That means, let's say we have an array like this: 1, 2, 3, 4, and maybe 7, 5, 6, 9, and 10, 11, 12, 10, 11, 15. Okay. So now, if you look at this, there is one small part of the array which is not sorted. What part is not sorted? So right now, if you look carefully, that this part is sorted, this part is sorted, this part of the array is, it's a sub part or a sub array. It's not sorted. It is not sorted. Okay, but you need to tell me the indices of the smallest sub array that needs to be sorted so that the entire array becomes sorted. I want to sort the entire array. That means in this case, the smallest sub array. See, there can be many arrays that you can sort. For example, if you sort this entire array, if you sort 4, 7, 5, 6, it will become 4, 5, 6, 7, and then the entire array will become sorted. Yes or no? But that is not the smallest subarray. The smallest subarray is actually this array 756. I need to sort 756. If I sort this array starting from this index till this index, even if I sort this part of the array, the whole array would become sorted. Are you getting it? Let me know. Yes or no? Are you getting the question? So 1, 2, 3, 4. So this is the smallest subarray. So you need to find the indices of these elements. The smallest subarray that needs to be sorted so that the entire array becomes sorted. So what could be a possible way to solve this problem? It's very easy. Coming up with a basic solution is very easy. Siddharth says sort the subarray. So Siddharth, we don't know the subarray. So we are only given the original array. We don't know where the subarray is. Find the sorted parts. Two pointer approach. Okay. Okay. Let me give you some more examples. Okay. Mm, so let's say I have another array. Example 2, example 1. I have 1, 2, 4, 7, 10, 11, 7, 12, and let's say 7, 7, 16, 18, 19. So what is the subarray in this case that needs to be sorted? From 10 to 16. From 10 to 16 uh, looks reasonably correct. So we need to sort this subarray. No, 10 to before 16. If we sort this array, like this much part of the array, it should make the entire array sorted. 1, 2, 4, 7, 7, 7, 7, and then I get uh, 10, 11, 12, and then I have again 16, 18, and 19. Can you relate these two arrays somehow? Are you able to relate the two arrays somehow? Now suppose I sort the complete array. If I sort, let's say this is the original array, and I created a sorted copy of the array. I said I will use the arrays.sort function, and I create a copy of the array, let's say. Can you somehow compare these two arrays? What is the difference between these two arrays? Let me know. See, you can actually compare that. If I start comparing these two elements, is 1 equal to 1? Yes. Is 2 equal to 2? Yes. Is 4 equal to 4? Yes. Is 7 equal to 7? Yes. Is this 10 equal to 7? The answer is no. You will get the first index, you will get the starting index. Okay. How do you get the ending index? Shashank says I am not getting this. So Shashank, in the programming language, we have a arrays.sort function. Did we discuss this function arrays.sort in any of the classes? Okay, so we did discuss it. Okay, so I said that okay, you create a copy of the array and sort it. You say okay, I created a copy of the array and I sort it, and then I'm comparing the two arrays, original array and the sorted array, index by index. So at the first index where there is a mismatch, that means that will give me the starting point of the subarray. Yes or no? The first index where they differ. How do I get the ending index? How do I get the ending index? Similarly, check from the end. Great. So 19 and 19 equal, 18 and 18 they are equal, 16 and 16 they are equal, 7 and 12 they are not equal. So I get an index. Okay, this is the ending index. Hence, uh, this is the subarray from start to end that needs to be sorted, so that I will um, right, so that I'll get the ending index. Okay, now the array from start to end that will give me uh, the subarray. So this will be the subarray that we need to sort. What would be the time complexity of this approach? So arrays.sort function, it takes n log n time. Okay, now then you need to do a comparison. Okay, you need to say while let's call this array as arr, and let me call this as array as barr. Okay, so you say okay, I equal to 0 while arr of I is equal to b array of I. You do something like I plus plus. So whenever this I stops, you know the I value. Similarly, you put another loop for j. You say okay, j equal to n minus 1 while arr of j is same as barr of j. I say j minus minus, and then you know what is the value of j, and finally it's going to be return ij. That's going to be your answer, right? Something like this, or print ij. That are the indices of the array. So now this function is n log n. This function will take at most n time, this will take at most n time, so it will be overall order of n log n plus n, which is order of n log n. Great. What about space complexity? This is time. What about space? Since we are creating a copy of the array, so it's going to be take order of n space. So any doubts in this approach, let me know. Prashant says got little confused. Prashant, which part? The approach or the coding? What part is not clear? Coding part. So Prashant, I said I need to find out the starting index. Let's say this index is I. So I'm comparing that if ARR of I is same as this value. If these two are same, then do I plus plus. If these two are same, then do I plus plus. If these two are same, do I plus. These two are same, do I plus plus. So finally, 10 and 7, they are not same. So what will happen? That 10 is equal to 7. This condition is not true, and hence we will stop. So once we know that the starting point is actually I. Are you getting it? Prashant, similar thing we did from the end. We said, okay, we took a variable j, which is at n minus 1. We compare these two. If they're equal, we come here. They're equal, we come here. If they're equal, we come here. Now they are not equal, so we stop. So we say, okay, the ending index is going to be j after this loop is over. Got it? So finally, your answer is ij. Gangadhar says, is this the solution or we will optimize again? What do you think? क्या लग रहा है मतलब? Needs to be optimized, but how? Can how you can optimize? What if two suffer needs to be sorted? No. The question says one part. Okay, you cannot change the question. The question is one sub part of the array is unsorted. Will the same approach work if multiple subarrays are not sorted? It will not work. Two pointers can work. But how? The question is how. So carefully look at this. Could this be the case we are not allowed to use array dot sort? No, it's not the case. Array dot sort is allowed. But right now we will discuss a new approach where we will do this question without actually sorting the array, without taking extra space or without creating a new array. Let's do it in the same array. Okay. So let me talk about another approach. See, if you look carefully, right? If you traverse this array, okay, so in the final array that is actually sorted, you see this is the index where earlier 10 was present, but now there is some other element that is present. Yes or no? Can I say this will be the smallest element in the array? array that is not in its correct position. That is not in its correct position in the original array. Can I say this is the smallest element in the array that is not in its correct position in the original array? Yes or no? And what about 12? Can I say this would be what? This would be the largest element in the array that is not in the correct position in the original array. So my first question to you is, can we can we find the smallest and the largest elements directly from this array? Okay, before that, I wanted to find out the elements in the original array which are not in the correct position. So we have 1, okay, we have 2, we have 4, we have 7, we have 10, then we have 11, okay, then we suddenly got 7, then we got 12, we got 7, we got we got a 7, then we got 16, then we got 18, and then we got 19. So can you tell me how I can find the elements which are not in the right order in the original array? Come on, tell me. So I want to check that I want to maybe make a Boolean function that if an element is out of order, is out of uh, order, that means is not in correct position, let's say, or I call it as is out of order. I give you the array and I give you the index. You need to tell me that whether this index is out of order or not. So we are just doing it for one index. So I'm saying, okay, is this 2 out of order? Is 2 out of order? Yes or no? Of course, no. Is 7 out of order? The answer is yes. So what is causing this out of order? See, if an element is in the right index, it would be smaller than the next and it would be greater than the previous. If it is a sorted array, then the ith element would be less than the next and it will be greater than the previous. Okay. So I simply say that if the element array I, okay, if this element array of I is greater than array of I plus 1, that means this comparison is reversed, or array of I if it is less than array of I minus 1, then I should return true. Yes or no? That means this element is out of order. Okay. But it could be possible that we are checking for the zeroth element. So if there is a zeroth element, we just need to check that if it is smaller than the next element. So for the zeroth element, the previous comparison does not need to be done. So I need to put another condition if I is 0, I just need to check that uh, return that if the array of I is it greater than array of I plus 1. I just need to check is this element bigger than the next element, then yes, it will return true. Now, so this condition should be and no. See, it could be one of these conditions. Now, like 7 is less than 12, which is okay. But 7 is also less than 11. This is not okay. Okay. So if the array is increasing, then 7 can be less than 12. That is okay. So that means if one of these conditions is false, then we should say, okay, yes, it is not out. It is out of order. So one of these conditions, right? Okay. Another condition could be for the last element. If I'm talking about the last element, so for that I just need to compare with the previous element. Now suppose if the last element is less than the previous element, if array of uh, like if I is equal to n minus 1, okay, what I should do? I should check that if it is greater than or if it is less than if array of I, if it is less than array of I minus 1, then also it is out of order. Okay. Okay. Basically, I should move this condition here because like the corner cases should be checked first. First check, second check, third check. But if none of these conditions return true, then you can say return false. Something like this. Are you getting it? We are repeating. Okay, let me write it little bit in a cleaner way. Let me write somewhat more cleaner. Right? See, I simply want to check that if the element is out of order or not. That is what I want to do, right? So now I have three corner cases. If the element is a first element, the last element, or some middle element. Okay. So I want to do it for every element, but there are three types of elements. A corner element. So for corner element, the first, if I is 0, right? It does not make sense to compare with the previous element because the previous element is not there. So I can simply say that return is this out of order if array of I. Now this would be wrong if 1 is greater than 2. So I say okay, return out of order if array of I is greater than the next element. That then it means 1 is not the right element. Suppose you have 10 followed by 2. Now of course it is out of order, right? 10 cannot be greater than 2 in a sorted array. If else if I is the last element, then the last element should be ideally smaller than greater than the previous element. But now suppose something like this happens, the last element is second last element is 18, but the last element is 16. So we know 16 is out of order, 16 cannot come here. So what should I write? Return, come on, tell me. Return what? Return true if array of I is less than array of I minus 1. If 16 is less than 18, then please return true. Otherwise, return false. So this will give me a boolean value automatically. Else, if there is a middle element, then the middle element is expected to be smaller than the next element and greater than the previous element. This is the expectation. But if something goes uh, not according to this expectation, I should return to. So else if one of these conditions is false, that means let's say else, right? Simply else, I can say return if 7 becomes greater than the next element, or 7 becomes less than the previous element. Then in if one of these conditions is true, you return true, that means it is out of order. But if one of these conditions is false, like both are false, then you say okay, then it is in the right index. Okay, so that's what. So this expression will automatically give us true or false. This will give us true or false. This will give us true or false. So even if we get true from some point, that means the element is out of order. Okay, so this will tell me okay whether the element is out of order or not. Now, how do you get the smallest element that is out of order? How do you get the smallest element that is out of order? Absolutely correct, Vinay. So for every element, calculate the min and max. So let us iterate on this array and let's keep a track of minimum and maximum. So minimum and maximum. So now what is our array? So array is 1 2 4 7 1 2 4 7. Let's iterate directly on this array. So I start the iteration from here. Is one out of order? So quickly you have to tell me in the chat, yes or no. No. Is 2 out of order? No. Is 4 out of order? No. Is 7 out of order? No. Is 10 out of order? No. Is 11 out of order? Yes. The expectation from 11 is it should be lesser than the next element, but it is greater than the next element. So this condition fails. That AI is less than AI is greater than AI plus 1. So this condition is now true. The first one. Okay, so that means it is out of order. So what is the largest element you have seen till now that is out of order? So the maximum so far is 11. Okay, great. Is 7 out of order? Of course, yes. So what is the maximum you have seen so far? Sorry, minimum is also 11. The maximum is also 11. Now, the minimum will be updated as 7. The maximum will still remain 11. Okay, because of the way how you update min and max. Is 12 out of order? Yes. So what will get updated? Maximum. So maximum would be 12. Great. Is this 7 out of order? It seems. Yes, it is out of order. So it's not minimum till now. So we don't update it. Is this 7 out of order? Yes. Is 16 out of order? The answer is no. Is 18 out of order? No. Is 19 out of order? No. So we got to know that the minimum is 7 and the maximum is 12. Great. But how do we get the index in the actual array? So the actual array was 1, 2, 4, 7, 10, 11, 7, 12, 7, 7, 16, 18, and 19. Now, how do I find the correct indices from this min and max? How do I find the correct indices from this min and max? Okay, index after min. Absolutely correct. So now you will try to find out that if I want to insert this 7 in the array, at what location should I insert? So should I insert after 1? No. Should I insert after 2? No. Should I insert after 4? No. Should I insert after 7? Maybe. Should I insert after 10? Obviously no. I should insert this element at this index. This is where the 7 should go. Are you getting it? This is the index where I get an element that is just larger than 7. So that means this is the index where the 7 should be actually present. Okay, how do I find where the element 12 should fit? What should be the condition? So you say okay, I equal to 0 while array of I is less than equal to the minimum element, you say okay I plus plus. So as soon as you get an element that is just bigger, your loop will stop. Okay, this would be the condition. Sheetal. So as soon as you get an array of I that is just larger than the minimum, it will stop. How do I put the index 12? How do I put from the 12th index? Start from the index, start from the end for the max end. Absolutely correct. So I say, okay, I have a j which begins from n minus 1. I say, okay, can I put 12 here? No, because 19 is greater. Here, no. Here, no. Here, should I put 12? Now I get an element that is just less than 12. That means, yes, this is the place where I should put 12. So 12 should come before 16. So that means while array of j is greater than equal to max, I say j minus minus, and I will get to know the final value of j. So if I print ij, that will give me the smallest subarray indices. Are you getting it? Okay, so this is what you will get, and you actually did not sort the array and you still got the indices of the subarray that needs to be sorted. Okay, great. So what is the complexity of this approach? So what was the first step? So you first checked that for every index from 0 to less than n minus 1 I plus plus, you checked, okay, if array of I is out of order, then you updated the min and max. Update and you update the max. So what is the complexity? So this code is order n. This code is also order n. So in total, TC is order n. What about space? Order 1. Absolutely correct. We did not use any extra space and hence it is order 1. Great. So congratulations if you understood this problem. It was not an easy problem. It was a hard question, okay? While loop, why order n? So worst case now, it is the worst case. It will maybe run till the middle, but maybe in the worst case, I can say it's going to be max order n. Okay. So we don't know if it is n by 2 or n by 3, but let's assume the worst case. Min and max explain this part, right? So Arpita, it is just like saying that, okay, out of all the elements that you have seen which are out of order, so what are the elements we had seen which were out of order? So 11, 7, 12, 7, 7, okay. So now what is the smallest element out of these elements? So these are the elements which are out of order. So what is the smallest element? You know how to find the smallest element. You already know it. You make a comparison with the current minimum, and you if you get a smaller element, you update it. This is how you do finding the minimum of n numbers. Okay. So if you find the minimum of these elements, you know it's going to be 7, and if you find the maximum, it's going to be 12. So we are just finding out what is the minimum and maximum out of all the elements which are out of order. That's it. So if we know them, then we are finding their positions. So finding elements here, and these two loops are finding positions where they could fit in the actual array. Got it? Okay. So with this, can you explain the third return statement? Oh, this one, right? Sure, sure. Okay. So see, what I'm saying is that if you have something like this, let's say I have an element 8 and I have a 10 here and I have a 6 here. Is this element out of order? Oh, 6, 8, and oh no, it's not the right thing. Let's say 16 here. Is this element out of order? Yes. Why? Because now 8 is less than 10, which is okay. AI is less than sorry, AI is greater. Okay, so now see, if AI is greater than AI plus 1, it is not the case. It is okay. This is correct. In an increasing array, this is expected that the next number would be greater than the previous number. But this is not expected that AI is less than AI minus 1. So what is happening? AI minus 1, this is AI. This is AI minus 1. If 8 is somehow less than the previous element, then what? Return true. That means, yes, the element AI is out of order. So 8 is out of order because 8 is appearing after 16 and it should have a value higher than 16. Okay, so the other case says so. The other case might be you have 8, you have 6, but the next number is even lesser. Let's say 5. So is AI greater than AI plus 1? Is 8 greater than 5? If you have something like this, then also 8 is out of order. So hence, true or false becomes true. True or true is true. Like means it can be both. It could be one of these cases. Okay. Are you getting it? Who had this doubt? Nagaraju. Okay. So this is what we are doing, right? So only when the case you have everything in the right order, you have 6, 7, and 8, something like this. 6, 7, and 8. So in this case, is AI greater than AI plus 1? No, it's false. 7 is not greater than 8. Is 7 less than 6? That's also not true. So that means false or false. Hence, the 7 element is not out of order and it is in the right place. So right means not out of order and we should return false if it is in the correctly positioned. Okay, got it? Great, great. Okay, so now you can go through the notes. You can revise this class if needed. I think this one was a little complicated problem, but rest of the class was bit easy. But still, I hope you got to learn lot new stuff today, and we'll meet you again next week with uh, fresh topics. Okay, so arrays is almost finished. We'll do some, I think, one more session on arrays on some interview questions. Okay. Yes, Cheetal. Oh my God. So it's very hard to interpret this code. Have you posted contest questions? What does it mean? Today, very early. So Sheetal, I suggest you please raise a TA help request. I won't be able to debug this code at this moment. Okay. Uh, so any help related with the code, you should raise directly with the TAs. Okay. All right. So we'll leave you early. Have a great weekend. Bye bye and take care. Good night. Do we get any break for intermediate? So you roughly have, I think, 4 or 5 days of break in which you have a test. That's the only break you have. So your beginner ends on 20th. Your intermediate starts on 26th. So you have 5 day break. Okay. Yes, there will be a contest. Contest will start after 18th of May. It will start after 18th May, not now. Okay. Oh, okay. So the beginner contest. So that one, I think that is available in your dashboard. Uh, so look into your dashboard. That must be available in some contest section. Okay. Lot more classes. Okay. You are in the intermediate. You are already in the intermediate. There will be a contest. Arey yaar. Sorry, I got confused. I was actually talking about for a beginner batch that I'm taking. Okay, so there won't be any test for your batch. I just got confused with the other batch. We are in the intermediate batch. You don't have any test. You don't have any break. Okay, it was for the other batch. Sorry, extremely sorry. So that means I need some rest. Bye bye and take care. Okay, bye bye.